So we are discussing multiplication algorithm. Yes, is it audible? And is it
Sir,
visible?
screen is not visible.
Yes.
Not visible.
Screen is now it is visible, kada?
Yes.
So everything is working. Yes, yes. Okay. Ah. Okay. We are discussing multiplication algorithms. Okay. So in this class, I will discuss about the concept Booth multiplication algorithm. Okay. So Booth multiplication algorithm. Okay. Booth multiplication algorithm. Okay. Okay, fine. See, in the last algorithm, what we discussed is the multiplication for signed magnitude data. Okay, signed magnitude data we discussed. Now, this Booth algorithm will discuss the procedure for multiplying binary integers in signed in signed 2's complement form. Okay, in signed 2's complement form. So both multiplicand and multiplier both are in signed 2's complement form. In the previous algorithm, what we discussed, it is a signed magnitude form. The binary numbers are in signed magnitude form. Okay. So here, the main principle in the Booth multiplication algorithm is, so when 0 occurred in the LSB of multiplier, okay, so there is no addition, and just it will shift the multiplicand. Just it will shift the multiplicand. Okay, and a string of ones in the multiplier from bit weight 2 power k one minute, okay, 2 power k to 2 power m can be treated as 2 power k plus 1 minus 2 power m. I will explain in detail. Okay. See, for example, how we can represent 14? How we can represent 14? The binary form. We can represent 14 in 1110. Is it right? Yes. The binary representation.
Yes, right.
Okay. So 1110. Okay. So it has the number of ones in which places. This is 2 power 1 place, and this is 2 power 2 place, and this is 2 power 3 place. 2 power 3 place. Okay. Now take this one as 3, which is k, and take this one as m. Okay. So here the number of ones are starting from 2 power 1, 2 power 2, 2 power 3. Of course, the 0 bit is here, it is 2 power 0 kada, the bit weight. Now, this can be represented like this. 2 power k is 3, so 3 plus 1 minus, okay, sorry, This is m is equal to 1. Okay, now m is equal to 1. Okay, so 2 power 4 minus 2. How much it is? 16 minus 2. So 14. Okay, 14. So any binary number can be represented like this. Can be represented like this. Okay. For example, m we are taking it as a multiplicand. Okay, multiplicand, and 14 is a multiplier. 14 is the multiplier. If we take m is multiplicand, for example, 14 we are taking as a multiplier. So multiplication operation, can be done like this: m into 2 power 4 minus m into 2 power 1. Okay, m into 2 power 1. See, 2 power 4 minus 2 power 1, we can represent that as a 14. 14. So 14 is a multiplier, and m is a multiplicand. M is a multiplicand. So if you perform this operation, we will get the multiplication. We will get the multiplication. See what it stands for. What is it stands for here? Okay, so m into 2 power 4, it is nothing but the multiplicand m is shifted left by 4 times. Okay, shifted left by 4 times, which is m minus now m shifted left by 1 time. Okay, so m is shifted left by 4 times. We will get one binary data. That binary data minus, and this multiplicand is shifted left by 1 time. We will get one binary data. Okay, so this binary data minus this binary data, we will get the multiplication. We will get the multiplication. Okay, so this is the thing here. See, I'll explain again. So how 14 can be represented? So 14 can be represented as a binary form like this: 1110. Okay. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, like that. So number of ones is from 2 power 3 to 2 power 1. Okay. Now we can represent this number as 2 power 3 plus 1 minus 2 power 1. That means here 2 power k plus 1 minus 2 power m. Okay, we can represent like this. So we are taking, for example, 14 as a multiplier and m as a multiplicand. Then how to form a multiplication operation? So m into 2 power 4, we got 2 power 4 here, minus m into 2 power 1. M into 2 power 1, we'll get the multiplication. So what is the meaning of this one is? That means the multiplicand m is shifted left by 4 times. We will get one binary code minus m is shifted left by 1 time. We get another binary code. So subtract these two binary code. We will get the multiplication operation. We will get the multiplication operation. Okay. So visible. So which color is visible to you? No. Only. Yes. Okay, fine. Now, what are the rules? What are the rules for booth multiplication? Is it visible what I am writing here? Are you convenient with
Yes,
this
sir.
one? Yes?
Yes,
Okay,
sir.
fine. Okay. So rules for booth multiplication. We are having some rules for booth multiplication. Okay. So first rule is the multiplicand. The multiplicand is subtracted. I will write here. Multiplicand is subtracted from the partial product when the first LSB, least significant bit, is 1. Okay, in a string of S mute ones in the multiplier. Okay, so multiplicand is subtracted from the partial product when the first LSB in a string of ones. Okay, first LSB is 1. Okay, first LSB is 1 in a string of ones in the multiplication. Okay, that means if LSB is 1, LSB of what? LSB of the multiplier. Okay, if the LSB of multiplier is 1, LSB of multiplier is 1, so multiplicand is subtracted from the partial product. Okay, from the partial product. Okay, so second one, multiplicand is added. Multiplicand is added to the partial product. Okay, to the partial product. To the partial product when the first when the first LSB, that means when the first LSB is 0. Okay, LSB is 0. So one is provided that, okay, there was a previous, that there was a previous one. Okay, in a string of zeros in the multiplier. Okay, that means if we got 0 and LSB and previous, if you got 1, then add the partial product to the multiplicand. Okay, see, actually what we are doing means here we are shifting. Suppose this is the LSB. Okay, this QN we are taking as a LSB. This is the multiplier. Okay, so this is the multiplier and this is Qn plus 1. Okay, so only this is the multiplier. This is the multiplier. Initially we will put this is 0. Okay, initially we will put this is 0. Okay, so if multiplier that is LSB is 1. Okay, if LSB is 1, what we are getting? We are doing the subtract operation. Okay, we are doing the subtract operation. Okay, after doing subtract operation, next we will shift this one. We will shift right side. We will shift right side. Okay, so if previously after shifting this is 1 and this is 0. See, this bit is LSB and this is another flip-flop, okay, which will store 1 bit. And if this occurs, we will do some addition. Okay, we will do some addition. Then last one is S silence. So partial product does not change when multiplier when the multiplier bit is identical to the previous multiplier bit. Okay, that means present multiplier, sorry. So present multiplier is 0 and previous multiplier bit is 0, or present multiplier bit is 1 and previous what is before shifting it is equal to 1. So if both are equal, so we want to do anything. We want to do multiplication. We want to do addition or we want to do addition. Okay. So this is the rules. Just I will explain in detail. By taking the flow chart. Okay. By taking the flow chart, I will explain. So before taking the flow chart, I will draw the hardware for both algorithm. So any algorithm can be understood by seeing the flow chart. Okay. So what is the hardware behind this one? What is the hardware? So we are taking one register BR. BR register we are taking, and we are taking another register which is a sequence counter. Okay. Then of course, as usual, we are having another block. What is that one? Complementer and parallel adder. Okay. So next we'll take the register, accumulator register we are taking. Okay. So BR register is the input for complementer and the parallel adder, and this is the another input. Is accumulator register is the another input for complementer and parallel adder. Of course, after the result is stored in the accumulator. And we are taking another register. Okay, QR register. Okay, QR register. So the LSB, what we are taking it as a QN. Okay, so we are using another flip-flop. So which are we are taking it as a QN plus 1. Okay, QN plus 1. So this is a simple block what is simple the block diagram for both algorithm. So here the BR register. Okay, so BR register contains a multiplicand. BR register will contain multiplicand. Okay, all right, here it contains a multiplicand, and QR register will contain the multiplier. Okay, so BR register will contain multiplicand and QR register will contain the multiplier. And the number of multiplier bits is equal to the counter for the sequence counter register. Okay, suppose we are having 5 bits in the QR register. That means multiplier is having 5 bits. Then sequence counter will be 5. Sequence counter contains the number 5. So it is a counter. It is a counter. So multiplicand and what is this one? Initially we are taking accumulator register as a 0. Accumulator register as a 0. Okay. So accumulator and BR register contains and added. Okay, and added, and complementary operation will be taking place if we perform the subtract. Okay. So the result is stored in accumulator. The result is stored in accumulator. Then afterwards, we will shift the total contents of accumulator register and QR register right times by ones. We are shifting accumulator and QR registers contents right side. We are shifting by ones. Then we will do addition operation or subtract operation, or we are not doing any operation. That depends on these two bits, qn and qn plus 1 bits. Okay, qn and qn plus 1 bits. Okay, now I will draw the algorithm here. Okay, I will draw the algorithm so that you can understand it very well. You can understand the very well. That means algorithm can be explained easily by using the flow chart. Okay, I will use the flow chart here. So flow chart for please concentrate on the flow chart so that the total concept you will understand by understanding the flow chart of both algorithm. మీకు ఒక్క ఫ్లో చార్ట్ అర్థమైతే టోటల్ కాన్సెప్ట్ మీకు అర్థమవుతుంది. ఓకే, టోటల్ కాన్సెప్ట్. ఓకే, సో ఫస్ట్ multiplicand in BR, multiplicand in BR, multiplier in which register? QR register. Okay, multiplier in QR register. Yes, multiplicand in BR and multiplier in QR. Okay, now initially we are setting accumulator is equal to 0. Okay, initially we are setting accumulator is equal to 0 and qn plus 1 is 0 and sequence counter is n. Okay, sequence counter will be n. N is the number of bits present in the multiplier. The number of bits present in the multiplier. Okay. Now I will check. The what is qn plus 1. I will check. Okay, I will check the two bits Qn and Qn plus 1. Okay, so if it is 0, 1, if it is 0, 1, then I will simple, what I will do? I will perform the addition. That's simple. That means AC plus BR, AC plus BR. Okay. So I will do the after addition AC plus BR. That means accumulator plus BR register contents will be added and the result is stored in the accumulator. Okay. Accumulator I will perform. Then if the bits are equal, that means 0, 0 or 0, 1. Okay, 0, 0, 0, 1. Then what I am doing means arithmetical shift right. Arithmetical shift right. A registers and A accumulator and QR registers. Then my sequence counter is decremented. My sequence counter is decremented. Okay. Here after adding, just I'm going to this operation. I'm going to this operation. Okay. So if Qn and Qn plus 1 are 1, 0. Qn and Qn plus 1 are 1, 0. What I'm doing here, accumulator minus BR. Okay. That means accumulator plus 1's complement of BR plus 1. Okay. Then the same operation I will do. Okay. Now here I will check. After that I will check whether sequence counter is equal to 0 or not. Okay. If sequence counter is not equal to 0, it is not equal to 0, then I will go to this step. Again I will check Qn and Qn plus 1. I will check here. Okay. If it is equal to 0, if sequence counter is equal to 0, just end. Okay, it is end. Okay, this is end. So initially, multiplicand is stored in BR register, multiplier is stored in QR register. Okay. After that, I will initialize accumulator as 0 and Qn plus 1, that is a flip-flop what I am using. It is equal to 0 and the sequence counter is initialized as n, where n is the number of bits present in the multiplier. Okay. And see, this is a Qn and this is a Qn plus 1. Okay. Now Qn is the LSB. Okay. Qn is the LSB of multiplier and initially I'm making this is as a 0. This is as a 0. Okay. Now if Qn and Qn plus 1 is 0, 1. Okay. Okay. Whether what is initial I'm put it as a 0 kabati. Okay. I will check here it is as a 1. Okay. So if Qn has 1 and Qn plus 1 is equal to 0, then what I will perform? I will perform subtract operation. That is AC minus BR. AC minus BR అంటే ఏంటండి? AC plus 2's complement of BR. And the result is stored in accumulator. Then I will do, after that I will do arithmetic shift right operation. So for what contents? Accumulator and QR register contents I will do. Okay, if I shift right, if I shift right here, so these will be moved to the what is Qn plus 1. It will be moved to the Qn plus 1. Okay, it will be moved to the Qn plus 1. Okay, and my sequence counter is decremented by 1. If it is not equal to 0, again it will go. Again it will go. Okay, so if it is 1 0, same it will do operation. But if it is 0 1, that means Qn and Qn plus 1 are 0 1. Okay, if it is 0 1, what I'm taking, I am doing the addition of accumulator and BR register contents, and the result is stored in the accumulator. Okay, then I will do arithmetic shift right, contents of accumulator and QR register. That means this one. So these accumulator register and QR register are shifted right side, so that the LSB is stored in Qn plus 1 flip-flop. Okay, this flip-flop. Okay, and it will be treated as Qn plus 1. Okay. Okay, now again sequence counter is decremented by 1. Okay, now if Qn and Qn plus 1 both are 0 0, both are 0 0 or both are 1 1, that means Qn and Qn plus 1 both are equal, then simply shift right, arithmetic shift right, contents of accumulator and QR register and sequence counter is decremented by 1. Okay, so at last I will check sequence counter is 0 or not. If it is not equal to 0, again I will do the operation like addition or subtraction or simply shifting. Okay, so sequence counter, if it is equal to 0, the process stops here. The process stops. Okay, so this is the flow chart of both algorithm. Okay, so before taking the example as a multiplicand is some one binary data I will take now, multiplier another binary data I will take. So before doing that example, are you having any doubt? Please ask the doubt. Up to now. Yes, any doubt? Yes, are you following? Akshita, Vaishnavi?
Yes, sir.
Yes, sir.
Okay. Bharat Reddy? Bharat Reddy. Now, I will take one example. Okay, I will take one example here. Okay. Yes, I will take one example. So in this example, multiplicand I am taking. Okay, so multiplicand I will erase this one. Okay. So multiplicand what I'm taking as 1 0 1 1 1, and multiplier I'm taking 1 0 0 1 1. Okay, so 1 0 0 1 1, and it is stored in BR register and it is stored in QR register. Okay, so multiplicand 1 0 1 1 is stored in BR register and 1 0 0 1 1 is stored in QR register. Okay. Now here actually we have to perform what is accumulator minus BR, accumulator minus BR. Okay, so what is the 2's complement of BR? What is the 2's complement of BR? Two's complement of BR means how much? Entandi? 0, 1,
1's
0,
complement
0,
plus 1.
1. That means 0, 1, 0, 0, 1. Okay. 0, 1, 0, 1, 0, 0, 1. Okay. So having this data, now this is the example I have taken. Okay. Now, so Qn plus 1, Qn and Qn plus 1, and this is the accumulator. This is the table I'm taking here. This is the accumulator, and this is the QR register. This is the QR register, and this is Qn plus 1, and my sequence counter. Okay, my sequence counter. Okay. Now, initially, accumulator contents are 0. అంతే కదండి. See, multiplier bits are 5 bits. So accumulator contents all are 5 zeros. That is what is my first step in the flow chart. Accumulator are cleared. Okay, accumulator are cleared. And QR. What is QR? 1, 0, 0, 1, 1. And initially I will make Qn plus 1 is also 0. See the flow chart. Okay, if you observe the flow chart here, yes, flow chart, AC 0, Qn plus 1 0, and sequence counter is n. Sequence counter is n. Okay, now sequence counter n means how many bits multiplier is having. How many bits multiplier is having?
5 bits.
Yes, it is a 5 bits kabati. So my sequence counter is a 5. My sequence counter is a 5. Okay. Now Qn plus 1 ante endandi. See, this is Qn kada. LSB of QR register is nothing but the Qn. Okay. Now Qn is 1, Qn plus 1 is 0. That means this is 1 and this is 0. Okay. Now what operation I have to perform?
Subtract.
Yes, we will perform subtract operation. We'll perform subtract operation. Subtract BR from accumulator. Subtract BR from accumulator. That means accumulator minus BR. That means accumulator plus 2's complement of BR. 2's complement of BR. Okay, so what is the 2's complement of BR? 0, 1, 0, 0, 1. Okay. Now you will add here 1, 0, 0, 1, 0. Okay, now. So accumulator minus BR means accumulator plus 2's complement of BR. So 2's complement of BR is 0, 1, 0, 0, 1. Now I am adding accumulator plus 2's complement of BR. I got 0, 1, 0, 0, 1. Okay. Now what is the next one? Arithmetic shift right. Arithmetic shift right. See what arithmetic shift right means. The sign bit keep it as it is, and you have to shift the total magnitude right side. That is the meaning of arithmetic shift. Okay, but in the normal shift right, including sign bit, you have to shift. But arithmetical shift right or arithmetical shift left means you have to keep sign bit as it is and magnitude only you have to shift. Okay. So ఏమొస్తుందండి అప్పుడు accumulator is this is the case 1 0 0 1 1 0 ఇప్పుడు ఏం చేస్తున్నారు మీరు ఇప్పుడు రైట్ సైడ్ షిఫ్ట్ చేస్తున్నారు సో 0 0 1 0 0 1 1 0 0 1 1 okay total is shifted right side. Total is shifted right side. Okay. And now Qn plus 1 becomes previous Qn. Previous Qn. Ante kadandi. Now accumulator contents are 00 100. Now QR contains 11 001. Okay. Now Qn plus 1 is equal to 1. Okay. Now what is Qn and Qn plus 1? Now this is 1. Qn is equal to 1 kada ippudu. Qn is equal to 1. Qn plus 1 is equal to 1. So both are 1. If both are 1, that means both are equal. What we have to perform? What we have to perform? We won't perform addition, we won't perform subtract. Just we will do shift right, arithmetic shift right. Okay. If Qn and Qn plus 1 are equal, we'll perform just arithmetic shift right. We won't perform addition, we won't perform subtraction. Okay. So we will perform arithmetic shift right. Okay. ఇప్పుడు ఏం చేస్తారండి 0 0 0 1 0 0 1 1 0 0 1. Total accumulator and QR is shifted right side. Right side. Now what is Qn and Qn plus 1 now? ఎంతండి ఇప్పుడు Qn plus 1?
0 and 1.
Yes, 0 and 1. Now 0 1 అయితే what operation we have to do?
Addition.
Yes. Add BR. Add BR with accumulator. Add BR with accumulator. Okay. So what is BR? BR is how much? 1 0 1 1 1. Okay. So both we have to add. That means this one and this one we have to add. ఏమొస్తుంది అడిషన్ చేస్తే 1 1 plus 1 is 0 1 1 plus 1 is 0 1 1 and this is a 1 and this is the 1. Of course previously you were having 0 1 1 0 0 1. Okay. Oh sorry, here after okay, I have not seen the sequence counter. I have not seen the sequence counter. Here, after arithmetic shift right, the counter will be decremented by 1. So 4. Then again it becomes 3. Again it becomes 3. Okay. Now after adding, what is the operation you have to do? Arithmetic shift right. See, whatever the operation you will do, subtraction, addition, the shifting is compulsory. Shifting is compulsory. Okay, shifting right is compulsory. Okay, so arithmetic shift right here. Okay, so arithmetic shift right. ఏమొస్తుందండి అప్పుడు 1 minute. Okay, so arithmetic shift right, what you are doing is here, this is MSB Gati, so total we will insert 1 here as a new MSB and 1 1 0 0 1 0 1 1 0 0. Okay. Now this is arithmetic shift right. This is arithmetic shift right. The MSB is 1. Okay. The MSB is 1 here. The MSB is 1. So in the new MSB here, we are placing here it is a 1. Now we are placing here it as a 1. So what we got? 11100110100 we got. Okay. So now here both Qn and Qn plus 1 are 0 0. Both are 0 0. If both are 0 0, what we will do? We'll perform again arithmetic shift right. We'll perform arithmetic shift right here. Okay, both are only one more arithmetic shift right. So arithmetic shift right. So again we must be inserted 1. So total this is 1 0 0 1 0 1 1 0. Okay, 1 0. Okay. Now here after this shifting here, so it becomes 2. It becomes 2. Now here now it becomes 1. So after every shifting, the counter becomes 0. The counter becomes 0 here. The counter becomes 0. Okay. Now 1 0 1 0. That means Qn is 1 and Qn plus 1 is 0. So what operation you have to do? Subtract operation you have to do. Okay. Subtract operation you have to do. Subtract BR. Subtract BR means accumulator contents plus 2's complement of BR. Okay, 2's complement of BR means here 0 1 0 0 1. Okay, so what you will get? So you have to add this one and this one you have to add. So you will get 0 0 1 1 1. Okay, 1 1 1. Of course, you are having here 0 1 0 1 1. Of course, previously it is also 0. Okay, now arithmetic shift right. Because MSB is equal to 0, the new MSB is also 0. Okay, so 0 0 1 1 1 0 1 0 1 1. So now sequence counter becomes 0. Okay. Now what is the result you got? The result is in accumulator. Okay. The result is in accumulator and QR. Okay. So this is the case here. So any doubt here you are having? So this is both multiplication algorithm. Okay, so this is both multiplication algorithm. So if you are having a note, please as a doubt. Yes, any doubt? Yes. So please ask the doubt if you are having. Okay. So one thing you have to understood that we are not doing simple shift right. We have doing arithmetic shift right. Okay, arithmetic shift right we are performing. Okay. So we have to check we have to check which operation we have to do. Student. Okay, we have to check here which operation we have to do. That means if qn plus 1 is equal to 0, 1. If it is 0, 1, we have to perform simple addition. If qn plus 1 are 1, 0, we have to perform AC minus BR. That means AC plus 1's complement of BR plus 1, so that it becomes AC plus 2's complement of BR. That is accumulator plus 2's complement of BR register. Okay. Then if the two bits are 0, 0 or sorry, this is 1, 1. Sorry. This is 0, 0 or 1, 1. That means if both are equal, both bits, that is qn and qn plus 1, both are equal, simple we will perform arithmetic shift right. Arithmetic shift right, and the sequence counter is decremented. Now we will check the sequence counter is equal to 0 or not non-zero. 0 or non-zero. Okay, if it is non-zero, again this process starts. The sequence counter becomes 0, just the process end. Okay, this process end. So that's why we are checking. Okay, that's why here we are checking what is qn and qn plus 1. We are checking here qn and qn plus 1. Okay, 1 minute. We are checking qn and qn plus 1. If it is 1, 0, if it is 1, 0, we'll do the subtract operation and shifting right operation. And if it is 1, 1, okay. So if it is 1, 1, if it is 1, 1, just we will do arithmetic shift right operation. Okay. And if it is 0, 1, if it is 0, 1, we'll do addition operation and arithmetic shift operation. Okay. Next, if it is 0, 0, that means both are equal. Both are equal, so we'll perform arithmetic shift right operation. Again, if it is 1, 0, so subtract operation and both. That means arithmetic shift right. Now, for each operation here, the sequence counter is decremented by 1. Previously, it was 5. Now 4, 3, 2, 1, 0. If it is 0, the process will stop. The process will stop here. Okay. So that is the concept behind both algorithm. Okay. So any doubt here, please ask the doubt. Yes. Please ask the doubt if you are having any doubt. Sadvika, ready? Any doubt, ma?
No doubt, sir.
Surya Prakash? Surya Prakash?
No doubts.
Deepika? Rakesh? Okay. So, any doubt, please ask the doubt. Okay. Otherwise, please leave the class.